infinity. I'll give you a way where you can just read off the answer. Okay, suppose you have the limit as x goes to positive infinity of a rational function, one polynomial over another, say am x to the m. Now, I want to give you some notation. For example, if I want to write a fifth degree, I'll say something like 3x to the fifth plus 4x to the fourth plus 7x cubed minus 2x squared plus 4x minus 11. But I'm also going to write 3x to the fifth plus lower terms. Lower terms. These are the lower terms. Okay? Those are the lower terms. That is what I'm writing up here. Some constant times x to the n. Plus, then the next is going to be x to the n minus 1 with a constant in front. That constant will be called a sub n minus 1. Same subscript as the power. Plus a sub n minus 2 x to the n minus 2. All the way down to a1x plus a0. But I'm just going to write down this plus LT, lower terms. So amx to the m plus lower terms. And in the bottom, I'll have well, there's no reason why the denominator also has to be to the nth power. We'll say the bottom is to the nth power plus LT. Okay. If n is 5, then LT is the constant to x is 4 plus the constant times x cubed plus the constant times x squared plus the constant times x plus the constant. Now, this limit is going to be very simple. It equals 0 if n is bigger than m. If the power, the highest power in the bottom, is bigger than the highest power in the top. Okay? It's going to be plus or minus infinity if the higher power is in the top. And you get the sign, whether it's plus or minus. Get their sign from a sub m over a sub n. Divide these two numbers, whatever the sign is, that's the sign you keep. If am over an was negative, then you should say the answer is negative infinity. You actually get the division of those two coefficients if m is equal to n. Okay, that's it. 3 simple rules. So if you have the limit as x goes to infinity of 3x to the 7 plus 4x cubed plus 7x minus 9 over negative 4x to the 9th plus 3x to the 5th minus 2x. In fact, you don't even need to look at the lower terms. The highest power in the top is 7. The highest power of x in the bottom is 9. Since the power in the bottom is larger, the limit is 0. Since n is bigger than m, you're done, 0. If the highest power of x is in the denominator, limit is 0. Move on to the next problem. Okay. The limit as x goes to infinity of negative 7x cubed plus 2x minus 13x to the 7 plus 9 all over 2x cubed minus 4x to the 5th plus 13. Just deal with the terms with the highest power, including their signs. Well, since the highest power is in the numerator, the answer is plus or minus infinity. Negative 13 over negative 4 is positive. What on earth am I doing? I'm taking the number in front of x to the 7, taking the number in front of x to the 5th, the numbers associated with the highest power of x, including their signs, and I'm doing basically negative over negative is positive. The answer is positive infinity, done. Okay, we did one where the highest power was in the numerator. We did one where the highest power was in the denominator. I take it as time to do one where the highest powers are equal to one another. For example, the limit as x goes to infinity of negative 7x to the 5th plus lower terms. That is, x to the 5th is the highest power of x. And in the bottom, you have 3x to the 5th plus lower terms. Possibly these lower terms will be plus 2x cubed minus 7x plus 9. But it doesn't matter. It doesn't matter. And these lower terms are, I don't know, 4x cubed plus 13x. Basically, you look at the terms that have the highest powers. Since the powers are equal, just divide the numbers in front. Negative 7 over 3. That problem is done. Finding limits at infinity, very, very simple. You need to know the rules. Can't play the game unless you know the rules. And you should think about why this is true. Okay. Let's just do a couple more examples. Then I'll give you a formal way of doing it in case your teacher wants you to show you your work. So, limit as x goes to infinity of 3x cubed minus 2x to the 4th plus 13x plus 11x to the 10th. And this is all over 13x to the 4th minus 12x to the 11th. Since the highest power of x is in the denominator, the highest power of x in the top is 10, in the bottom it's 11. The highest power of x is in the bottom, it's 0. We don't even have to talk about x to the 10. If the highest power is in the bottom, it's 0. The highest power is in the top, it's infinity. That's probably the better way of saying it. Okay? If the highest power is in the top, it's infinity, plus or minus infinity. You have to divide. Well, okay, actually, let's scratch that. Let's do it the way we say. If the highest power is in the bottom, it's 0. If the highest power is in the numerator, for example, if I take the same exact problem, but I flip it over. Same exact problem, but I flip it over, the highest power in the top is 11, the highest power in the bottom is 10. That means the answer is plus or minus infinity. How do we tell? We take We look at the sign of the term that had their 11th power. It's negative. We look at the term that had the highest power in the bottom. Its sign is positive. The overall sign is negative. This limit is negative infinity. And this is how you study. You don't even have to practice tons and tons of these problems. Learn those rules. Learn, well, when I have limits at infinity, I'm just going to look for the highest power in the top, highest power in the bottom. If the highest power is in the bottom, the answer is 0. If the highest power is in the numerator, it's infinity, but I'm not done. I have to find the sign. I look at the signs in front of those terms that had the highest power, negative over positive. I do that division and I get my sign. If the degrees are the same, 3x to the 5th minus 11 over 2 minus 4x to the 5th, the answer will be negative 3/4. Why? Because the powers are equal, so I divide the numbers in front of those terms. 3 over negative 4. The 3 is understood to be positive. Positive over negative is negative, and 3 over 4 I can't reduce. The answer is just 3 over negative 4, which is negative 3/4. So you can read off these answers. Now, unfortunately, and it takes a matter of seconds to know the answer. And it's always good to know the answer before you try to solve the problem. Now, if your teacher allows you to do what I said, wonderful. If your teacher says you have to show some kind of work, well, not a big deal. Suppose first you have to realize that if you have 1 over x, and x is getting bigger and bigger and bigger, 1 over a really large number. You have one pizza pie, one big round pie, and you're sharing it between a lot of people. You're dividing it amongst an awful, awful lot of people. An awful lot of people. This is approximately 0. And if you squared it, the bottom is even larger. If you raise it to the 4th power, this number to the 4th power is even larger. It's going to 0. 1 divided by a very, very large number is 0. 1 divided by a very, very large number is approximately 0. Make this large number larger, it's close to 0. Make it even larger, it's closer to 0. In the limit, it is 0. Okay, so just understanding that 1 over a large number is 0, we could show some work on these limit problems. For example, if you had 3x cubed minus 2x plus 5, and you're dividing by 4x to the 6th minus 5x cubed plus 2x. The largest power in the denominator is x to the 6th. So I'm going to divide every term by x to the 6th. I'm going to take 3x cubed divided by x to the 6th. I'm going to take 2x divided by x to the 6th. I'm going to take 5 divided by x to the 6th. I'm going to take 4x to the 6th divided by x to the 6th, etc. We divide every term by x to the 6th. So now I am showing my work. I divide every term by x to the 6th. Okay, so let it say x to the 6th and not x6. try this again. Okay. And then, well, maybe I lied. I said we're dividing by x to the 6. I denoted we're dividing by x to the 6. Now let's actually do the division. This will be 3 over x cubed minus, this will become 2 over x to the 5th plus 5 over x to the 6th. And in the bottom, this will just be 4 minus, this will become 5 over x cubed plus 2 over x to the 6th. Now, since x is going to infinity, not 0, that's what I meant. Well, this goes to 0. 3 divided by a real large number cubed is 3 divided by a real large number. You take 3 pieces of candy and you share it between 30 billion people, they each get 0. Okay, these go to 0. They go to 0. So the numerator is like 0 minus 0 plus 0. I got the signs from here and here. So the numerator is 0. And the denominator, well, as x goes to any number, infinity or what have you, 4 stays 4. Minus, this goes to 0. This goes to 0, and we add those zeros. And the bottom is 4. 0 over 4 is 0. But this is exactly what we expected because the denominator had the larger power. Okay, so here it is worked out. Here, just write down the answer. Possibly your instructor wants you to show the work. So here was a case where the denominator had the larger power. What if they're equal? We'll do the same exact thing. What if they're equal? What if you have the limit as x goes to infinity of 7x to the 5th minus 2x cubed plus 4, and we divide by 3x to the 5th plus 4x to the 4th plus 2x. Now, we know the answer is 7 over 3. The highest powers are the same. The answer is 7 over 3. Okay? And it only took a second. The thing is, if we have to show the work, at least now we know the answer. The largest power in the bottom is 5. So I'm going to take each term in the bottom, each and every term, and divide by x to the 5th. And divide by x to the 5th. I'm going to take each and every term in the numerator, and I am going to divide by x to the 5th. I'm going to divide by x to the 5th. And most of these things will go to 0. Now I do the division, and I basically say most of these go to 0. This one goes to 7 minus, this becomes 2 over x squared plus 4 over x to the 5th. 4 over x to the 5th. And this is 3 plus 4 over x plus 2 over x to the 4th. Well, as x goes to infinity, that goes to 0. That goes to 0. 4 over x goes to 0. 2 over x to the 4th goes to 0. So, I get 7 minus 0 plus 0. 7 for the top. Well, that of course is 7. And in the bottom, I get 3 plus 0 plus 0. 3 plus the 0 plus the 0. Well, that's 3. And 7 over 3 is my answer. Just like I said 2 minutes ago. Okay, now let's let the numerator have the larger power. So the whole thing here is you have to know how to divide, x cubed by x to the 5th. And for review, do that at the end. Limit as x goes to infinity of 3x to the 6 plus 2x minus 11 over 22x to the 4 plus 3x cubed plus 9x. Well, since the numerator has a larger power, it's going to be infinity, and here they go, those are the largest powers. I divide the numbers in front, and whatever sign I get, that's what I keep. Positive 3 over positive 22 is positive. So, to show my work, I divide by the largest power in the bottom, namely x to the 4th. So for now, I'm going to denote them. Dividing by x to the 4th. In the top, I divide each and every term by x to the 4th. This equals the limit as x goes to infinity of to the bottom. X to the 4th cancels out. You get 22 plus 3 over x plus 9 over x cubed here. In the numerator, you get 3x squared plus 2 over x cubed minus 11 over x to the 4th. Now, when x is real large, this goes to 0, and this goes to 0. To the bottom, this goes to 22. 22 plus 0 is 22. This goes to 0. This goes to 0. This goes to infinity. Positive infinity. Positive infinity. This goes, so positive infinity plus 0 minus 0 is positive infinity over positive 22. The sign's positive infinity. Okay. So I'll give a quick review on how to divide these things. Possibly I should have done that at the beginning. You have 3x to the 4th, and you divide it by x to the 6th. The 3 stays. Since the larger power is in the bottom, x goes in the bottom. And do the larger power minus the smaller power. And that's the new power, 2. If you have 13x to the 10 over x to the 6th, the 13 stays. I meant to say 16. Since the larger power is in the bottom, x goes in the bottom. Do the bottom power minus the top power. You put x in the bottom, you do the bottom power minus the top power, and that's the power. For the record, if for some reason you wanted to put x in the numerator, you would do the top number. If you want to put x in the top, you do the top number minus the bottom number, which is negative 6. But we don't want to do that. Okay, if you want x in the bottom, and we do in these problems, you do the bottom minus the top. You do whatever the larger power is. Somebody asked me what x to the 7 over x squared is. I would ask myself, which power is larger? The one on top, x goes in the top. Then I do the top power minus the bottom power. Somebody asked me what x to the 6 over x to the 8 is. Since the larger power is in the bottom, x goes in the bottom, and I would do the larger power minus the smaller power. And there's always a 1 if nothing's on top. Okay, next set of problems is, there's more than one infinity. There's negative infinity. If I ask you, what is the limit as x goes to negative infinity of some function? Well, don't do that. Do the limit as x goes to positive infinity. But wherever you see x, or minus x. That is, for example, the limit as x goes to negative infinity of 3x squared minus 4x plus 5 over 4x cubed minus 2x plus 9. You can say that this is the limit as x goes to positive infinity. But then instead of x, put negative x. Instead of x, put negative x. Instead of x, put negative x. Now to argue why this is right. Here, when you square negative infinity, you should get positive. Okay, what's being squared here? It's negative infinity. So negative infinity goes in for x. Well, what's being squared here? Negative x. So if x is infinity, you'd be squaring negative x. But that's what the top line says. Here, you are multiplying 4 by negative x. Same thing down here. If x is infinity, then you're multiplying 4 by negative infinity. In the bottom here, you're cubing negative infinity. If x is positive infinity, then you are cubing negative infinity. Here, you're multiplying 2 by negative infinity. You're doing the same thing here. Okay, and then you should clean it up a little bit. For example, negative x squared is x squared, so it's 3x squared, and minus 4 times negative x is plus 4x plus 5. And the bottom, negative x cubed is negative x cubed, times 4 is negative 4x cubed. And then negative 2 times negative x is positive 2x plus 9. And now follow the rules for limit that plus infinity. Let's see, since the largest power is in the denominator, the answer is 0. Okay, replace x with negative x and take the limit as x goes to as x goes to infinity. To convert from a limit as x goes to negative infinity, write it down as a limit as x goes to positive infinity. For in the function, wherever you see x, put negative x. Clean it up, take the limit. Alright, that's limits at infinity. Hope I did a good job.